In this next example, the table shows us the percent of the U.S. adult population with diabetes, both diagnosed and undiagnosed, and shows how that is projected to grow rapidly in the future. So I'm assuming that the first couple of these are probably from some known statistics. 15.7% of U.S. population with diabetes in 2010, 18.9% in 2015, 21.1% in 2020, and so on. But then eventually it starts projecting these numbers. So it's predicting that, for example, by the year 2050, that 34.3% of the US adult population would have diabetes. So this is asking us to find the power model that fits the data with X equal to the number of years after 2000. So again, it's asking us to align our data. So we don't actually want to put in the year itself as the X value, but we want to put in the number of years after the year 2000. So that means since our first one is 2010, that would be 10 years after 2000. So we'd have an X value of 10, and then an X value of 15, and then 20, 25, and so on. So first thing I want to do is just put that into my graphing calculator. So I'm going to go to Stat, and then to Edit, and I'm going to clear out my old data. So then I'm going to put in my X values into L1. So 10, 15, 20, and intervals of 5 here all the way up to 50. And then in L2, I'm going to put in the percents that they've given me. I don't need to put in percent symbols. I'm just going to put them in just the way that they've given them to me in the table. And I'll just remember that these represent percents. So once my data is in here, I'm ready to create a scatter plot of that. So just to check and see that everything's set up correctly, I'm going to go to Stat Plot. So second and that Y equals button. And I can see that my plot is already on. So if yours isn't, you would need to turn it on, but I have it on from the previous problem. So I don't need to change anything there. However, I am also going to check Y equals, and I can see that I've got some things from my previous problem in here. So I'm just going to clear out what's in Y equals so that I'm not seeing that by mistake. So this is all I need to make a scatter plot is I just need to turn my stat plot on and have my data entered. However, if I hit graph, I'm probably not seeing all of the points because I need to tell it to zoom to where those points are. So the fast way to do that for a scatter plot is zoom and then zoom stat. So this is what my points look like. And I can see that I could fit a line to this data and it would probably fit pretty well, but there is a slight curve. So they're suggesting that I use a power model. So often we would use a quadratic or a power model when there might be a curve to our data. Technically, a quadratic is a parabola shape and it has that turning point, whereas a power model doesn't have a turning point. That may or may not make a difference when you're just looking at part of that graph fitting your data. So sometimes we actually just try several things. We might try a line, we might try a quadratic, we might try a power model, and then just end up picking the one that fits best. So in this one, though, the instructions tell us use a power model. So we're going to go to Stat and then over to Calc. And then this time I'm going to choose, rather than linear or quadratic, I'm going to choose a power regression model, which is PWR-REG, stands for power regression. And I'm going to select that option. My X values were in L1, my Y values are in L2. Since I'm going to go ahead and graph the equation that it gives me, I'm going to tell it where I want it to store that. So on the line that says store reg EQ, I'm going to go to vars, over to Y vars, choose function and choose Y1, which is telling it that I want it to store the equation in Y equals or in Y1. And then hit enter and again hit enter to calculate that. So I'm going to use f of x instead of y, but it's the same thing. So they're giving me f of x equals a times x raised to the b power but A is, if I round to 3 decimals, this is 4.947, and then times X, which is raised to the 0.495 power. So that's my equation for my power model that fits this data. And since I told it to store that, that means it should graph that automatically now if I hit graph. So that looks like a very good fit. It is going through or very close to almost all of those points. So then we want to use this. So this is our model that seems to be predicting what's going on here for the years from 2010 to 2050. And so part B is asking us to use the model to predict the percent of US adults with diabetes in 2026, right? So if they're asking for a particular year, remember that X was the number of years after 2000. So this is really saying that it wants us to consider an X value of 26. And so it wants us to find the percent of US adults with diabetes, which means it wants to know what Y value would you expect if X was 26, right? And we've got data in our actual table, we have data for 2025 and 2030. So we could estimate it, it's going to be somewhere between 24.2 and 27.2, but we can actually use the model to predict this. So one thing you can do is you could do this by hand. We're really just saying use this model, this equation that they gave us, but then also use an X value of 26. So you could quite literally just substitute in 26 in the place of X and see what you get for Y or for f of X. So I think in this case, if you do that, you get 24.8. But guys, your calculator already does this. Since my equation's already in my calculator, I can actually just go to table and see this value. So I'm going to go second and then that graph button to get to the table. And then I just scroll down to an X value of 26. So since I know the X value, this is going to be exact. I'm seeing 24.856, and if you actually arrow over to that, it'll give you actually all the decimals there, or a lot more decimals. So 24.85555 and keeps going. I'm going to say that's really just about 24.9%. So on this one, I think if you did it just by plugging it in, because we rounded those numbers, you get 24.8%. Technically, since the calculator, when they use the table, they're not rounding. It's a little bit more accurate. So actually it rounds up to 24.9%. And either is fine, right? 24.8% or 24.9. Either of those are acceptable. All right, so that would be our answer then for part B. And then part C, it says, in what year does this model predict the percent to be 30.2? So this time, instead of it giving us the year or the X value and asking for the Y value or the percent, it's going the other way. So it's saying, when I have a Y value of 30.2, what would that X value be? So since I'm already in the table, if I just want to approximate this, I would just keep scrolling through my table until I find as close as I can to a Y value of 30.2. I think in this case, yeah, that looks like it's going to be an X value of 39. So it's not exact, but it's probably good enough for our purposes, at least on this problem, to say that an X value of 39 or 39 years after the year 2000 is when we would expect this to be 30.2%. But if you want to calculate it exactly, what I would do is go to Y equals. I want to leave my equation in there from part A because I'm still using that. But then I would just go down to Y2 and put in this Y value of 30.2. Then when I go back to graph it, I can see now I've got not just this blue model that is my power function that fits my data and predicts things here for me, but I also have this red line which represents 30.2%. And so what I want to do then is have the calculator tell me where does this intersect. So I'm going to go to Calc, second, and the trace button and choose intersect. And then anywhere you want to be on the first curve, meaning that nice blue curve on mine, hit enter. And then you can be anywhere you want to be on the second curve. And the second curve is just that horizontal line at 30.2. And then it wants you to guess. So I'm just going to move as close as I can to where they actually intersect and hit enter. And it calculates this exactly. So we had said it was roughly an X value of 39, but it turns out it's exactly an X value of about 38.5, right? 38.519 and keeps going. So that would just mean, 38 and a half years after the year 2000, which 38 years after the year 2000 would be 2038. But even half a year later, you would still be during the year 2039. So whether you use the table to approximate it or you actually had it calculate the intersection, you should be getting 2039.